Hello, mentors. In this video, we'll look at equivalent graphs. So those graphs are equivalent. That means they have exactly the same structure. So the same, lines and points in exactly the same configuration. It is not enough that they have the same number of points and the same number of lines. Let's start with an example. Let's look at these two graphs. So start with Olala and then Sia. And let's wonder, are these equivalent? And so both have four lines and 5 points, as you can see, but that's not enough. Maybe they have different structure, but let's think a little. Actually, we can see that they are equivalent. Let's justify why by using annotations. So we discovered that this dot here of Sia, it's exactly the same dot as Olala on the top, the Eiffel Tower, right? Pretty much. And then if we keep doing that using different colors, we can see that this neighbor of this yellow vertex or point appears here the same. So thus far, we have exactly the same graph, right? Just a yellow connected to a blue. Let's keep using different colors, and it's important to use all colors differently. So all the colors should be different. Green, green, so good. And then green splits into two more neighbors, right? So 3 in total. And then we're gonna succeed because look, we can do this here in Sia, do this here in Olala, and finally close with a nice blue color here and here. So if you look at this matching, this coloring, it's telling us that they are exactly the same graph. So same structure. It's just that they are arranged differently, right? So in space, Sia, it's kind of like the Eiffel Tower upside down, so to speak. So that's good. Let's look at another example now. So look at Racimo and Oso. Okay. Let's see, let's investigate Racimo versus Oso. So Oso means bear in Spanish. Racimo is just these 2 bananas, right? Put together. Think for a second. I'll give you 10 seconds to try to see if they're equivalent or not. And so what do? Well, we try to look for a matching. And so which of these nodes on the left of Racimo will play the role of the nodes on the right? So we want to match node with node, point with point, and see if they actually have the same structure. So Racimo is very interesting. It has exactly 1 point with 4 neighbors, right? So it's a pretty different point. So let's color it. It's a good idea to start. And let's wonder, is this also graph the same? Can we also find a point with 4 neighbors? And the answer is no, 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 yes. So this guy here on the bottom has also 4 neighbors. So that's promising, but we're far from, telling that they're equivalent. Let's see what happens. So what are the neighbors of this red point in Racimo? Well, they're this blue guy and this green guy here, right? So it has these 2 neighbors. What other neighbors do they have? So, well, 4 neighbors actually, right? So all these 4 neighbors. And let me use this yellow here for the last color. Can we do that there? Let's see. So let's start with the blue. And so let's put it, say, here. And so in Racimo, blue connects to yellow. So I gotta do that exactly as in Oso. So it's gotta be here. And so I have a little nice triangle, right? Like yellow, yellow, blue, and red. And that triangle, it's also 1 banana. It's just a weird triangle. And finally, if I just draw these green and pink points, so let's color them. I get a nice triangle, and take a look. It's exactly the same structure, like this bear became 2 bananas or the other way around. So these graphs are actually equivalent. last example. So let's clear. And now I claim that these two graphs are the same. So let me find more graphs that are the same. So I'm actually gonna do the following. I'm gonna look for a graph that looks similar to another graph. Give you 5 seconds so that you can try to find one. And okay, did you find one? I hope you did, because I did find one. So estrella, it's gonna be equivalent to, big surprise, the pentagon, right? So pretty different figures in geometry, right? The way we used to. But if you think about it, by untangling estrella, so, just stretching it, you actually get the pentagon. How do we make sense of that? Well, we just use colors. So let me do it with this, start with this red. So any point, so estrella, all points are the same, right? They just have two neighbors, so there's no special points. So I'm just gonna start anywhere. Same for the pentagon, right? So, and then I'm gonna do the two neighbors of the red dot in estrella. So here and here. And so I gotta replicate this structure, right? I gotta mimic what I just did in the graph called pentagon. So I gotta do this pink in one side, doesn't matter which side actually. And then I gotta do the yellow in the other side. So far, so good. We just have a line of 3 dots. Let's continue. So let me use green, and I can start any graph, it doesn't matter. So I'm gonna do green in pentagon and continue from there. And so green connects to yellow. So I gotta do that in the same, the same fashion in estrella. It feels like a game, right? Whatever I do in one place, I gotta redo in the other place by respecting the colors. And so I'm gonna just do that and put this green dot here. Okay, that's good. Notice that also in estrella, green and pink do not connect. Same in pentagon, so that's great. Finally, let me use the blue to complete the graph. And so blue connects to pink and green. Am I gonna be able to do it? Let's see. Oh yeah, this blue also connects to pink and green. So estrella is just a pentagon in graph universe. Finally, let me give you one example of graphs that are not equivalent. And so kids may be pretty fast and do it pretty well when it's time to find equivalent graphs, and you help them with the coloring. Now, arguing why graphs are not equivalent, it's a little harder. Let's try. So I'm gonna claim that oh la la, this graph here, it's not equivalent to the following graph. I'll give you 5 seconds to find a graph that's similar, but not quite the same. And I have one in mind, but I'll just wait for you to think. And of course, well, there's several options, but let me give you one option that it's not clear. It's not too clear because these graphs look quite the same. Both have 5 points, 4 lines. They have no triangles. But look, here's what happens. I just gotta find a property in one graph, and it goes back to meaning 2, a property in one graph that is not satisfied in the other graph. And then I can tell them apart. I can say that they don't have the same structure. Notice that plane actually has a center. So it has this point that connects to pretty much all other points. So it's a point connecting to all the other points, all the rest of the points. If plane and olala claim to have the same structure, I should be able to do the same in olala. But no matter where I put my, my red dot, doesn't matter where, it's not gonna be the case that I have 4 neighbors. I just fail. So not equivalent. Let me tell you which graph is equivalent to plane. And it's just right there, alga. So actually alga has a center, right? Meaning in graph theory, a point that connects to all other points. And let me use actually all colors, different colors, to make sense of this. And so let's try to do the same, what I did in alga, let's do it in plane. Yellow. Now I gotta go pink. And finally, gotta find the green. There you have it, same structure. I have a center, the red, and then I have these planets, floating around, just neighbors to the red. And these other four colors, they don't really share anything, right? They're not related. And you can see that that's the case in plane, and that's also the case in alga. Finally, another nice example of two graphs that are not equivalent are the elephant and the cometa. Let's see why. So first, let me annotate so that it's clear what we're talking about. Elephant and cometa, so similar, 5 points, right? I mean, there's also in both have a point that's almost isolated, only one neighbor. So looks pretty promising. And, you could think for a second that they're actually equivalent, but they're far from equivalent. For example, Elefante has a triangle, but Cometa has no triangle. So that's a property that can tell them apart, that can separate them, right? So Elefante, I can find, these lines that form a triangle. So it has a triangle, and Cometa, no triangle, doesn't have a triangle. Another way to, to tell them apart is counting lines. So here it works. Cometa has only 5 lines, right? 1, 2, 3, 4, 5. Whereas Elefante has 1, 2, 3, 4, 5, 6 lines. So if they don't have the same number of lines, automatically they're not equivalent. They cannot afford to having the same structure. But be careful, just having the same number of lines and the same number of points is not enough to conclude that they are equivalent. So have fun finding graphs, finding pair of graphs that are equivalent, and hope you enjoyed this activity. See you.